Hey everybody. So it turns out one of the videos, 9.1b, the audio cuts out when my computer glitches, and then something happened with the mic there perhaps. So I just wanted to voice over the video again so that you get that audio explanation for what's going on. We were about to do this example problem, taking that 30.12 inches mercury and converting it to atmospheres so we can compare it to 1 ATM as kind of a useful reference, since a lot of us don't have an idea of inches mercury, what's normal and what's not normal. So I'm drawing a little barometer over to the left, and remember that inches mercury is that height of mercury in the tubing. So because it's just a height length measurement, we can convert the length measurement of it. So instead of measuring that height in inches, we can measure it in centimeters. So we can convert it to centimeters with the 2.54 to 1. And then we can continue to convert it to millimeters. And that'll get us to millimeters mercury for the pressure, because what we're saying is, that the height of that column of mercury in the tubing is what in millimeters. So when you put that all through your calculator, what you get is 765 millimeters mercury. Because millimeters mercury and torr are the same unit, we can just say that that's 765 millimeters mercury. What I'm doing right here is just figuring out the sig figs. There's 4 significant digits in my measurement, so I get 4 significant digits in my answer because I'm multiplying and dividing. So the conversion factors we used are exact. So now let's take torr and convert it to ATMs. 765.0 torr. And it's 1 atmosphere is 760 torr. Apparently, I'm explaining that you want to keep the extra digits as you continue your calculation so you don't have round off error. So that's why I put the extra digit back in. So we multiply by 1 atmosphere over 760 torr, and we get a little bit over 1 atmosphere. So it was a little bit of a high pressure day. I think I recorded this on Tuesday, was the pressure on Tuesday. And then we get 4 significant digits. So the 6 will round up to 1.007 atmospheres. All right, let's see what happens next. Gonna be honest, I don't remember. I'm probably talking here. Who knows? Alright, so let's talk about how Torricelli barometers actually work. So Torricelli was the name of the Italian scientist who developed the first barometer. I think that was in, 1600s sometime. And so this is the barometer here. What we have is the pressure of the air pushing down on this open well or vat of water. And then the second force, what that's doing is pushing the mercury up the tubing. And the second thing is the weight of the mercury, and it's wanting to fall down because of gravity. So these two forces are in opposition to one another. And the height of the mercury tells us about the amount of pressure that the air is pushing down with. So if you wanted to do kind of a cheapo version of this at home, what we would have done is filled the whole tubing with mercury and inverted it into the mercury so that the vacuum is above it. But you could do this at home with some small cup or like Tupperware container that's something long with a smallish end. Fill it with water. Fill your sink with water. And if you invert that quickly into the bigger vat, you'll see that the water stays in the cup, right? So that's the same idea. And the reason that that water would stay in the cup, even if it's above the surface, or the base of it is above the surface, that would be from atmospheric pressure pushing down, you know, on this section of the sink, on the open to air part. So the main takeaway for how to read barometers is that the height of the mercury in the tube describes the atmospheric pressure. So if there's more atmospheric pressure, it'll push down more with greater force, and the height of the mercury will be pushed up higher. So it'll be a higher height if the atmospheric pressure is higher. So that's why 760 millimeters mercury or 760 torr are equivalent, because, you know, it either refers to the scientist torr or refers to millimeters mercury for the height. I think at the end of this video I had a couple of announcements. If they were important, they probably made it into the email that I sent out. So if anything comes up, please let me know if you have questions or whatnot. Otherwise, the next video deals with manometers and measuring gas samples as opposed to the pressure that it is just in our ambient conditions with the weather that we have. That's probably what I was talking about actually while the video ended, how high pressure systems and low pressure systems affect, you know, weather patterns and, you know, hot fronts and cold fronts and such. So it's very related to meteorology. That's the word. Sorry, I couldn't find it for a second in my brain. But, you know, we're not going to do like meteorology themed questions or anything. So I'm going to end this video. Thank you for bearing with the technical difficulties. And then, you know, just watch the rest of the videos that are in the page description and instructions. So unless you have extra time, then watch all of 9.1 to 9.3.